This is a demo of long context understanding, an experimental feature in our newest model, Gemini 1.5 Pro. We'll walk through a screen recording of example prompts using a 44-minute Buster Keaton film, which comes out to over 600,000 tokens. In Google AI Studio, we uploaded the video and asked, "Find the moment when a piece of paper is removed from the person's pocket and tell me some key information on it with the timecode." This screen capture is sped up, and this timer shows exactly how long it took to process each prompt. And keep in mind that processing times will vary. The model gave us this response, explaining that the piece of paper is a pawn ticket from Goldman & Company pawnbrokers with the date and cost, and it gave us this timecode 1201. When we pulled up that timecode, we found it was correct. The model had found the exact moment the piece of paper is removed from the person's pocket, and it extracted text accurately. Next, we gave it this drawing of a scene we were thinking of and asked, "What is the timecode when this happens?" This is an example of a multimodal prompt, where we combine text and image in our input. The model returned this timecode, 1534. We pulled that up and found that it was the correct scene. Like all generative models, responses vary and won't always be perfect. But notice how we didn't have to explain what was happening in the drawing. Simple drawings like this are a good way to test if the model can find something based on just a few abstract details, like it did here. These are just a couple examples of what's possible with a context window of up to 1 million multimodal tokens in Gemini 1.5 Pro.
This is a demo of long context understanding, an experimental feature in our newest model, Gemini 1.5 Pro. We'll walk through some example prompts using the Three.js example code, which comes out to over 800,000 tokens. We extracted the code for all of the Three.js examples and put it together into this text file, which we brought into Google AI Studio over here. We asked the model to find 3 examples for learning about character animation. The model looked across hundreds of examples and picked out these 3. One about blending skeletal animations, one about poses, and one about morph targets for facial animations. All good choices based on our prompt. In this test, the model took around 60 seconds to respond to each of these prompts, but keep in mind that latency times might be higher or lower, as this is an experimental feature we're optimizing. Next, we asked, what controls the animations on the littlest Tokyo demo? As you can see here, the model was able to find that demo, and it explained that the animations are embedded within the GLTF model. Next, we wanted to see if it could customize this code for us, so we asked, show me some code to add a slider to control the speed of the animation. Use that kind of GUI the other demos have. This is what it looked like before on the original Three.js site. And here's the modified version. It's the same scene, but it added this little slider to speed up, slow down, or even stop the animation on the fly. It used this GUI library the other demos have, set a parameter called animation speed, and wired it up to the mixer in the scene. Like all generative models, responses aren't always perfect. There's actually not an init function in this demo like there is in most of the others. However, the code it gave us did exactly what we wanted. Next, we tried a multimodal input by giving it a screenshot of one of the demos. We didn't tell it anything about this screenshot and just asked where we could find the code for this demo, seen over here. As you can see, the model was able to look through the hundreds of demos and find the one that matched the image. Next, we asked the model to make a change to the scene, asking, how can I modify the code to make the terrain flatter? The model was able to zero in on one particular function called generate height and showed us the exact line to tweak. Below the code, it clearly explained how the change works. Over here in the updated version, you can see that the terrain is indeed flatter, just like we asked. We tried one more code modification task using this 3D text demo over here. We asked, I'm looking at the text geometry demo and I want to make a few tweaks. How can I change the text to say goldfish and make the mesh materials look really shiny and metallic? You can see the model identified the correct demo and showed the precise lines in it that need to be tweaked. Further down, it explained these material properties, metalness and roughness, and how to change them to get a shiny effect. You can see that it definitely pulled off the task, and the text looks a lot shinier now. These are just a couple examples of what's possible with a context window of up to 1 million multimodal tokens in Gemini 1.5 Pro.
This is a demo of long context understanding, an experimental feature in our newest model, Gemini 1.5 Pro. We'll walk through a screen recording of example prompts using a 402-page PDF of the Apollo 11 transcript, which comes out to almost 330,000 tokens. We started by uploading the Apollo PDF into Google AI Studio and asked, find 3 comedic moments, list quotes from this transcript, and emoji. This screen capture is sped up. This timer shows exactly how long it took to process each prompt, and keep in mind that processing times will vary. The model responded with 3 quotes, like this one from Michael Collins, "I'll bet you a cup of coffee on it." If we go back to the transcript, we can see the model found this exact quote and extracted the comedic moment accurately. Then we tested a multimodal prompt. We gave it this drawing of a scene we were thinking of and asked, what moment is this? The model correctly identified it as Neil's first steps on the moon. Notice how we didn't explain what was happening in the drawing. Simple drawings like this are a good way to test if the model can find something based on just a few abstract details. And for the last prompt, we asked the model to cite the timecode of this moment in the transcript. Like all generative models, responses like this won't always be perfect. They can sometimes be a digit or 2 off. But let's look at the model's response here. And when we find this moment in the transcript, we can see that this timecode is correct. These are just a few examples of what's possible with a context window of up to 1 million multimodal tokens in Gemini 1.5 Pro.